What is radiometric dating? Don't worry, if you can't remember your age, Granddad, we'll get you carbon dated. Keep in mind that carbon is used to find the age of organisms that were once alive. At first, there was only relative time scale. It showed inferred order or sequence of events. Oldest layer of silt, youngest layer of silt, still settling through the water. This came first, second, still happening. The geological timescale then became an absolute numerical timescale using specific times when numbers and units of times, years, were determined. Part of the process involves isotopes. A parent isotope will undergo radioactive decay, and during this time it will give off heat and produce a daughter isotope. Chemical elements come in several forms called isotopes. We'll focus on these four: carbon-14, potassium-40, uranium-238, and rubidium-87. Isotopes can become unstable or radioactive. A radioactive isotope will break down naturally into different elements called a decay product. Carbon-14 decays into nitrogen-14. Potassium-40 decays into argon-40 or calcium-40. Uranium-238 breaks down into lead-206. Rubidium-87 breaks down into strontium-87. Half-life: the time required for half of the atoms in a sample of radioactive element to change to the decay product. For carbon-14, it takes 5.7 times 10 to the 3 years. Potassium-40, 1.3 times 10 to the 9. Uranium-238, 4.5 times 10 to the 9. Rubidium-87, 4.9 times 10 to the 10th. At the end of one half-life, a sample contains equal amounts of the radioactive element and its decay product. Each succeeding half-life, half of the remaining atoms decay. 0 half-lives, 1 unit of radioactive uranium-238. After 4.5 billion years, 1 half-life, 1 half of the original unit of radioactive uranium-238 remains. Another 4.5 billion years, 2 half-lives, 1/4 of the original unit of radioactive uranium-238 remains. Each half-life, the amount of atoms gets cut in half. Here we have 16 atoms. Let's imagine we have 16 carbon-14 atoms. After 1 half-life, there are now 8 carbon-14 atoms. After 2 half-lives, 4 carbon-14 atoms. After 3 half-lives, 2 carbon-14 atoms. After 4 half-lives, 1 carbon-14 atom. Here's what happens to the decay product. We start off with 0 atoms of nitrogen-14. After 1 half-life, we have 8 atoms of nitrogen-14. After 2 half-lives, we have 12 atoms of nitrogen-14. After 3 half-lives, we have 14 atoms of nitrogen-14. After 4 half-lives, we have 15 atoms of nitrogen-14. At the start, 0 years have passed. After 1 half-life, a total of 5,700 years have passed. After 2 half-lives, a total of 11,400 years has passed. After 3 half-lives, 17,100 years have passed. After 4 half-lives, 22,800 years have passed. If scientists analyze a fossil of an organism that recently passed away, they might expect to find 100% carbon-14 and 0% nitrogen-14. If scientists examined a fossil that's 5,700 years old, scientists would find 50% carbon-14 and 50% nitrogen-14. Finding a fossil with 25% carbon-14 and 75% nitrogen-14 would indicate that fossil is 11,400 years old. Fossil with carbon-14 levels at 12.5% and nitrogen-14 levels at 87.5% indicate that the fossil is 17,100 years old. A fossil with 6.25% carbon-14 and 93.75% nitrogen-14 would be dated to be 22,800 years old. The decay product ratio, the ratio between the mass of a radioactive element and its decay product in a sample. Here's the line that represents the radioactive substance. It starts off at 100%. After 1 half-life, it's down to 50%, then 25%, then 12.5, then 6.25, 5 half-life, 3.125%. The decay product starts off at 0. After 1 half-life, it's up to 50%. After 2 half-lives, 75%. After 3 half-lives, 87.5%. After 3 half-lives, 93.75%. And after 4 half-lives, 96.875. After the ratio is determined, we can calculate how many half-life periods have occurred since the sample was formed, and in turn determine its absolute age in years. Here's our line for half-life, mass of the original carbon-14 remaining, number of years. If we started off with 1 gram, after 1 half-life, we'd have half a gram. After 2 half-lives, a quarter. After 3, an eighth. After 4 half-lives, we'd be down to 1/16, then 1/32, and 1/64. To determine the number of years, we continue to add 5,700. If a sample contains the same amount of carbon-14 and nitrogen-14, how many half-lives have occurred? If it contains the same amount of carbon-14 as nitrogen-14, then it has 50% carbon-14, 50% nitrogen-14. That would indicate the sample's gone through 1 half-life, and in the case of carbon-14, that would mean that the sample was 5,700 years old. If the ratio in a sample is 3/4 nitrogen-14 and 1/4 carbon-14, how many half-lives have passed? To change that in percentages, we have 25% carbon-14 and 75% nitrogen-14. Looking at the chart, that's 25% carbon-14, 75% nitrogen-14, that's 2 half-lives. Since carbon-14 has a half-life of 5,700 years, 2 half-lives is equal to 11,400 years. The half-life for any element is not affected by environmental conditions, such as temperature, pressure, or chemical combinations. Selecting the best radioactive element for the sample to be dated must contain a measurable amount of radioactive element and its decay product. A sample containing the remains of living organisms, example plants or animals, is likely to contain radioactive carbon-14. Next, you must consider the sample's age. Carbon can date samples no older than about 50,000 years. Since carbon-14 has a very short half-life rate, at about the end of 50,000 years, there's very little carbon-14 left. It's very difficult to find carbon-14 in samples older than 50,000 years. Uranium-238 can measure samples of the oldest rocks on our planet. How long is uranium-238's half-life? You can find that answer on the reference table. 4.5 times 10 to the 9th years. That's 4.5 billion years. How old are the oldest known rocks? The oldest known rocks are found here on the reference table, and they date back about 4,300 million years, or 4.3 billion years. Which leaves us with rubidium. How long is its half-life? Rubidium's half-life is 4.9 times 10 to the 10th. That's 49 billion years. How old is the Earth? From the reference table, the estimated time of the origin of Earth and solar system is 4,600 million years ago, or 4.6 billion years ago. What is the issue? Rubidium hasn't even gone through a single half-life. Want to try a few Regents questions? How much of an 800-gram sample of potassium-40 will remain after 3.9 times 10 to the 9th years of radioactive decay? The half-life for potassium is 1.3 times 10 to the 9th years. How many half-lives have gone by after 3.9 times 10 to the 9th years? To find that out, I'm going to divide. By dividing the numbers, I've determined that 3 half-lives have gone by. If we start off with an 800-gram sample, after 1 half-life, we'll have 400 grams. After 2 half-lives, we'll have 200 grams. After 3 half-lives, we'll have 100 grams. Due to radioactive decay, an igneous rock sample now contains 1/4 of the amount of potassium-40 that it originally contained. The age in years of this rock sample is approximately. Okay, so if I started off with 100%, and now I have 1/4, 1/4, to get there I would have gone 100 to 50%, that's a half, and now their half-life would have gone from 50% to 25, which is now at a quarter. So I've gone through 2 half-lives, and since each half-life is 1.3 times 10 to the 9th years, and I've gone through 2 of them, that would give me 2.6 times 10 to the 9th years. How old is a fossil that has radioactive decayed through 4 half-lives of carbon-14? One way to solve the problem, instead of a chart, here's half-lives, here's years, 0, 1, 2, 3, 4. It's gone through 4 half-lives. At 0 half-lives, we had 0 years. At 1 half-life, we're at 5,700, and so on. So when we get up to 4 half-lives, we've totaled up to 22